a database that people can collaborate to and create like this big database, like a Wikipedia for LCI data is, I think, what it said on the website. And in order to be able to get different data together, you need a common vocabulary, some kind of common understanding on what you actually do. And this is kind of the first step that was introduced, was this Bonsai ontology. And the Bonsai ontology is a set of opinionated ideas on what, like if you want to do an LCA, what can be, like what things do you have? Like you have flow objects, you have an activity, you have an agent that might use something, you have quantity, you have time, and this ontology just describes how these things are connected, and it's very general, and you can basically use it to do to describe any type of LCA or any type of model. Yeah, and so this is the ontology. I don't have the time to go into it further, but you can look it up online. It's on GitHub. Yeah, and around like the time also, in order to try to facilitate the creation of this big project, the Bonsai nonprofit was created, and it still exists today. It's kind of has a very similar view as DDS that Chris presented yesterday. But over the last years, it kind of shifted focus from like this big collaborative effort to just building this Bonsai database. And the reason for that is that 5 years ago, the KR Foundation, which is a Danish foundation, decided to put money into this project and ended up funding 3 universities plus the 2 Zero LCA consultants, which I'm working for officially. And these partners together got the money to build this database, or like back then, what was the vision? The project was called Getting the Data Right, and it just finished this June. And so today I'm trying to present what came out of this, like what's the database that we created, and also what what the next steps are going forward. So we had a pretty big team. This is part of the team. I think we never managed to get all the team members at one location at one time, because we were spread out over, I think, 7 different countries. So this is from one of the last project meetings, but also Miguel, who is presenting afterwards, he's not part of the picture. Yeah, and our goal is to have transparency, traceability of data, have everything completely open source and open data, something that is easy to update, and something where the community can also contribute to. And where we are right now is, yeah, we finished the project, as I just said, and all the data or the results of the database are available on bonsai.uno. We code and develop completely out in the open on GitLab, so you can, we do our project management using GitLab, and so you can you can see what milestones we have, how far we are along, when we close issues and stuff like that, right? And right now we have further financing for a core team of 2.5 people for 1 year of maintenance. So like this time next year, this will be running out. And we hope that during the next year, we can really focus on making this from this closed team that was developing it the last 5 years to really make it something that's used by more and more people, and also gets contributions from more and more people. So that when funding runs out, it isn't just another database that dies somewhere, but it's actually being useful. One of the cool things about the database is that we developed it in such a way that it can be automatically updated with very little effort. So there's no need to update a bunch of Excel sheets or something like that. The idea is really that we try to use APIs to connect to statistical agencies wherever possible and stuff like that. So that hopefully, like, we plan on having yearly releases that are almost entirely automatically updatable. So what is this database about? It's an input-output database. So that means it's we have a top-down approach where we start from like monetary global trade views. We use supply and use tables where we know like which country is producing and using what kind of it's in sectors. It's usually very coarse, and then we refine those industries using physical data. For instance, we know how much we have a big agricultural sector, but then we have very detailed data from Faustat that tells us for different countries how much different feedstock agricultural products they produce, and then we can use that data to disaggregate these very coarse monetary flows, and we end up with a database where we have physical units. So we have not just like monetary flows. I'm going to go back to it a bit later. And in the final product that we have on the website right now, we have around 900 products for 43 countries and 5 rest of world regions. So we tried, because we're using these supply use tables as a kind of starting point, we really try to model the whole economy. So we have everything from extraction to transformation, consumption, and we also model waste and recycling. And as I said, we have this multi-layer approach where we have different layers that correspond to different units or different unit types. So we have the monetary layer, the mass layer, energy layer, distance layer, and some others that I didn't show here. The idea is that, and we, like, for instance, going from monetary to mass and stuff like that, we use like price information or disaggregation methods, other disaggregation methods. And we use that not only to then inform our final output in terms of using those numbers to calculate, but we also do balancing throughout that. So because we can, for instance, enforce mass, because we have this mass layer, we can enforce mass flow restrictions, like for instance, having certain processes that where we make sure that the carbon balance is kept, and we then balance each individual layer, and then also balance through the layers to try to make sure that we have the most valid results that we can achieve. And because this is a technical conference, I'm also going to talk now on how we set things up and like what our learnings are from like the technical perspectives of the last 5 years. We have most of our development in Python. We have a few things that we did in R, and we have 4 main separations. So we have like 4 main steps that we do in our pipeline. We have data collection and cleaning of data, where we, whenever possible, we connect to APIs. Sometimes we scrape websites for data, and then for some parts we use manually collected data because it's not available anywhere else. And then we clean the data. Then we have a next step where we harmonize it, because I mean that's like one of the very big steps is we have all of these different databases, and we need to try to make them talk to each other, right? So for that, we have a harmonization layer where we then transition all of these external databases to like our Bonsai classification. And then after that, it goes into the main modeling pipeline, which at the end produces hybrid input-output table. And with that hybrid input-output table, we then do the balancing on it and then the calculations to get to the final emission factors. And we do task orchestration using Apache Airflow. It's I have a like a screenshot a bit later, but it basically allows us to make sure that tasks are executed in the right order, and also make sure that we have a nice interface in order to track down problematic tasks or tasks that might fail. We have a library for data handling between tasks, because we try to make each task as independent as possible, so that then we need some kind of library to handle the data exchange between the different tasks. And then something else that we tried to do, and we did a lot of iterations on it, and I have a slide as well, but that's also something where we are very open to maybe ideas, is how we have these individual sector models that we use to refining and disaggregating like more aggregated flows. And it's basically kind of a mini LCA that we do. And yeah, regarding the task orchestration, we currently have 442 tasks in the whole pipeline, and they can be something like, for instance, we have one that's called collect USGS data that just scrapes the USGS website for all their Excel sheets. We have one that's called redistribute energy to incineration. We have one that's called merge supply tables before balancing. You can see it's like they have, they can be smaller, they can be bigger. Overall, we have 442 of them. And the way it works for us, or it worked best for us, was that we have task classes where we put them, and then we have workflow classes from which we then are able to automatically generate like a task registration pie, which like lists the entire workflow, and then we run Airflow to through Airflow we can run them in isolation. This is how Airflow looks like. It's not the most like on my tiny laptop screen. It's not the most nicest thing to look at, but it has very, very nice things like you, for instance, have a versioning system for graphs. So every time you update your workflow, it automatically detects that, and then you can compare the different versions and run different versions and stuff like that. It's yeah, a lot of very nice things. If you're interested, go talk to me afterwards. Yeah, then we have for the data storage and the schemas, we have our data IO package that helps us keep track of every read and write operation to the database, and or to wherever we want to write stuff to, if it's on disk or in a database or something. And it makes sure that it enforces schemas and vocabulary to use throughout the pipeline. And it allows us to have like one common interface between all the tasks. And for the vocabulary, we use PyST for publishing it. We hope that soon we are able to also use it for maintaining the vocabulary, but we are currently developing that. Because I don't have much time, I just briefly want to mention uncertainty, because that's something that we spend a lot of time on, and unfortunately, we don't have uncertainty yet in the database. We were able to crack the biggest bottleneck, which was the balancing. We're using Markov chain and Monte Carlo for it. Then here we have a quick overview of how we deal with these sector models that we're using for refining the data. And maybe most interesting for you, and that's also my last slide to Thomas. What's next? So right now we have this 2.5, like it's 4 people at the core team that keeps developing the database. We have the next big update end of October. And in the next month, we plan to have monthly releases of the database because we're still finding a lot of bugs everywhere. Miguel will also show you some, I guess. But it would be great, especially if you're in research, if you already start using the database and you just contribute with feedback and help us that way improve. You can, if you go to bonsai.uno, our website, you can have directly a button where you can open issues, where you can also find our GitLab, and also where you're able to contribute data if you want to, but it's very, very preliminary. And I've also already seen a lot of great ideas today and yesterday where we might borrow some in terms of how we want to facilitate that data contribution to the project. Thank you.
Thank you, everybody. Let's give a big applause for Valentin. I propose the following, since Miguel is also going to be talking about the Bonsai database in practical terms with Brightway. Let's keep the questions by the end of Miguel's presentation regarding what Valentin just presented so that we're not too late today on schedule. Is that okay with everybody? Yeah? All right. So you just heard about all the theory and how it all evolved, the Bonsai database, and now Miguel is going to tell us in practical terms, how can you actually use it and reuse it through Brightway? Normally, the notebooks that Miguel is going to show us right here are already available on the server. So if you want to follow the presentation by executing the same code that Miguel is going to show us, you can go ahead, start doing it, find a lot of things that don't work, make me stress. Or Miguel, I don't know. All right, good. The floor is yours, Miguel.
Hello, everybody. Can you hear me? Okay. So here you have a notebook where we can start to play with the database that Valentin just presented. As this is like this open source database, so I created an importer for using this database in Brightway in a kind of effortless way. The importer is currently sitting in a fork of the Brightway 2.io library, but hopefully we can integrate it soon in the main library. I don't think that should be a problem. So if we start executing things, should go to the top. Just need to import things. You need to create like a biosphere database because right now it's using the default biosphere of using Brightway. So if you don't have one, you create one, and then there's like some steps to import the database. First, you need like a mapping between the elementary flows in the database and how they are called in the biosphere database. It's essentially a dictionary of these codes to the code in the biosphere database. And you need to indicate a path to where the files are. In this case, in the repository, there's some Bonsai files that we put here. Let me try to open. Yeah, and this is just like a few relatively small files contain all the database, everything that you need. So you would like you need to import like this Bonsai importer, which is a subclass of a more generic IO importer that, by the way, can be used to import other input-output databases. And this creates a database which uses the input-output backend developed by Chris some years ago, especially for input-output tables. This backend is slightly different than the SQL backend, but it works fine. So you just need to run this importer. If you do it, I just did it before, so but it's quite quick. It doesn't take so long, and at the end you end up with a new database here, which is called Bonsai. So let's have a look to this Bonsai database. As I said, it uses the input-output table backend. It has around 42,000 activities. As Valentin hinted, there's sectors where we have much more details than others. So if you go to steel, you will see basic iron and steel. For the moment, we don't have anything better. We're working on disaggregating that into a bit more products. But in stuff like food, there's quite a lot because we can use a lot of data that is openly available through FAO. There's currently like 50 different locations. We can use like this nice visualization of the technosphere if you want. You can see it's more dense than a typical process-based LCA. But that's quite common in input-output, things that originate from input-output. But this is already something which is a hybrid between input-output and process-based LCA. It's not a purely input-output table. And you can run your LCAs as always. Just select one activity. For example, if I search for basic iron and steel and I take like the second one, this is steel in Sweden. There's some metadata on the activity, and more is to come. Like you have like the production volumes, the code, and some reference to what is produced, and so on. And if we select an impact assessment method, in this case, I just picked the typical IPCC global warming potential for 100 years, and you do like an LCA. Well, it doesn't take long to get some results. And as for other a normal database, you can calculate the characterized inventory, and I know you can display the contribution. This is, for example, the contribution by elementary flow. If you like this kind of drawings, or you can just do as you do usually on your Brightway projects, or a contribution by location. It seems most of the impact actually takes place in Sweden, probably because, yeah, this is primary steel production, so there's a lot of on-site emissions. And the other day, a colleague of ours invited us to a raclette in her house here in Grenoble. So I thought, well, let's put an example of a raclette. So if you are not aware of what it is, like, well, ask somebody from here because I will probably butcher the recipe. So, but it has cheese and it has potatoes, and it can have meat and other things. So you could, here for this example, I just took like a bunch of activities of cheese from goat milk, from cows, from sheep, a bit of potatoes and some bacon. And you can create like just a simple activity, this normal way. You can, maybe I've done this in a course or in your day-to-day tests of the database, and then you can access your raclette. We can iterate over the edges of the raclette. And you can see like different exchanges. And you can do like with Brightway 2 analyzer, like a recursive calculation and see what's the contribution analysis. You can maybe put it into a data frame and display like a graph and see, okay, most of the impact in our case seems to come from the cheese from cow milk, which is perhaps not surprising. And also nice things of this input-output databases is that you can also analyze the impact of consumption of a country. You can see all the impact of household consumption in France or in Sweden or whatever, all the countries that are represented in the database, or also like all the impact of government spending. So this is the final demand in input-output is organized into different like big sectors that consume, that are like the kind of the engine of the consumption in the economy. So you could pick, I don't know, here I took Ukraine, I think, and you can calculate also like the global warming impact or other impact scores. And if you want to look at how the data is stored, it's relatively simple. I mean, it's quite simple, actually. It's just like a compressed CSVs with that contain the non-zero values of the matrices, and also like kind of labels for like codes that represent like the indexes and columns of your tables. And some takeaways that here you have like a free and open source database that you can use for your LCA projects. We have still to iron out some of the details of the and correct some bugs, because if you start to use it, you will find bugs, and it will be grateful if you tell us. And yeah, we hope we can build a community that this is not just there is kind of a collaborative effort that we can together build like this open database for our industrial ecology efforts. And that's all.
Thank you very much, Miguel. So we now have 5 minutes for question. Yes, of course, there, Manuel. Well, I'll just bring the microphone to you, and then I'll come back here.
That was quick, thanks. The question comes up very often, I guess. But how can we make sure that your database aligns with EcoInvent, or how do we find out where like one or the other is wrong, or how they could complement? Like, what's your pathway towards that, or what kind of ideas do you have to make that possible?
So it's not an easy question to answer, right? I mean, the correct answer is you have to go into the processes and look at, for instance, the contribution and stuff like that, and then like figure out, like you need to figure out, like maybe for some processes it's super obvious. I know, like maybe one is 10, like has a factor 20, 30, 40, or like orders of magnitude different, and then it's quite obvious, like this can't be that. I know we had a bug where in like in some countries there's like half the household consumption comes from trucks. Like obviously this is wrong. Households don't use trucks, they use cars.
Okay, follow-up question, quick. So you know already of differences. Do you have like kind of a to-do list of the biggest differences that someone needs to work through, or
yes,
if that's the approach?
So we try to validate it against EcoInvent. I mean, maybe like not every difference is something we look into, but the big differences is definitely something we look into.
Okay, thanks.
Thanks for the presentation. I was wondering if you would model the raclette with Agribalis datasets, would you get to similar results or quite different, and why?
I have no idea, but I hope not very different. But I haven't really used Agribalis myself, but it shouldn't be very different. But
yeah, I'd be curious to see.
I mean, we can try, but for most of the activities, we get rather similar results to other LCA databases.
Well, that's a great follow-up question.
Yeah, you mentioned at the end that more elementary flows are coming soon. What elementary flows are currently in there, and do you know which ones are going to be coming soon?
I mean, what it's covered is, and it's not here in this presentation, is land use, fossil fuel use, like use of minerals. That's kind of things that we have like a global level, and we are going to add like water use as well, at least for crops. Am I like? Well,
I think that's the at least the short to mid-term what we try to aim at.
Yeah.
Just to clarify, that means you're not able to calculate EF method today with the 16 indicators.
I mean, for some methods, you will get very small results because the coverage in some elementary flows, it's not as extensive as in a process-based LCA, because there's like things that are not characterized. Like I don't know, like I was trying with the impact world, and for example for fisheries we get 0 because there's no resource extraction of fisheries currently accounted in the database.
We have an online question from Amelie Müller. She's asking that on the website, it's written that Bonsai follows a consequential LCA paradigm. Could you guys very quickly elaborate on this?
Yes, so the data that is online is following a consequential approach, but we try in developing the database to make it as unopinionated as possible for the longest part of the pipeline. So if you want to have attributional results, you can also do that, but you need to run it yourself right now. But that's if you want to contribute with a solver that does attributional, then we're very happy to include it into the repository.
Okay, and very quickly, Moritz, you have a question also online. If you unmute yourself.
Yeah, thank you very much. A very nice presentation. I just wondered why, when you said you're doing data graphing and searching, how do you ensure that you can update the prices? Like, how do you do that? Could you elaborate on that? Do you do it on a yearly or annual, or how often do you do that, and how does it work?
So we plan on having yearly updates and then also do yearly updates of prices. How?
Where will those prices come from?
I might write a detailed answer to that in the chat.
Great. Well, then let's thank again Miguel and Valentin from Bonsai. And Wes, if you're ready for your